In this video, let's answer the question of, is it a smarter thing to push a trolley or a lawn roller, than to pull it? So let me explain it this way. So this is your land and you are applying a force F at an angle of theta. And here in this case, you're pulling with a force F, and here too you're making an angle of theta. So in both the places we have mg itself, and here too you have mg. Now question is again, which is easier? So first thing first, let's shift this force to this point, so it's much easier to discuss. Then of course, as usual, we need to resolve this force. So we have something like this and something like this. So this would be theta, this will be mg cos theta, and this is sorry, not m, f. This is f cos theta, and this is f this is sine theta. Okay, yes. Right, this is all to do with resolving of forces. Let me zoom in. I think it'll be too small for you guys. Yeah, this is it. You can pause and have a look. And what is the one thing that I'm missing? Yes, friction. So we have friction also. I should have made this big diagram itself. Anyways, I made it. So that is your frictional force. Fk1. That's your frictional force. Done? Done and done? So now let's apply. Oh yeah, one more thing we forgot. Then we have your normal force. See, the question over here is, how much is the frictional force? Fk1 is what we are trying to figure out. Right? So that is dependent on your reaction force. Basically, we are looking at reaction force in both the places. So let's again do this over here. For that, again, I will zoom in a bit. So I'm shifting the force F from there to here. So that is your force. And then resolving it over here and over here. And this will be F cos theta, F sine theta, and yes, you have your frictional force. So basically, we are trying to compare Fk1 and Fk2. So now let me zoom out. So guys, basically we are trying to figure out which is greater, Fk1 or Fk2. Okay, so here too we have your reaction force, and the friction depends on reaction force. So we know that Fk1 is mu k. Mu k is constant for both because the materials involved is same in both, so Fk is constant. So what is going to vary is R, right? To figure out R, so to find expression for R, we will consider Newton's second law, which talks about the net force on an object. If I add all of them, it will give us the acceleration times mass. So net force over here, if I take up as positive, will be R minus mg minus F sine theta. That should be equal to 0. Right? It's not accelerating along the vertical. So this is applied along vertical along the vertical. So we have R is equal to mg plus f sine theta. Now let's substitute this in 1. Therefore fk1 is equal to mu k mg plus f sine theta. Agree? Right? Next, let's go to this. Here, what did I write over here? To find expression for R. To find expression for R. So applying Newton's second law along vertical. So we have R plus f sine theta minus mg. All of this is equal to 0. Therefore R is equal to mg minus f sine theta. And this we will substitute n fk, which is equal to mu k into R. Therefore fk is equal to mu k into mg minus f sine theta. Now fk2, I'll call this as fk2. So fk1 and fk2, can you have a look clearly? I'm not going to write the final statement, but fk1 is plus over here. Here this minus f sine theta, here it's plus f sine theta. So when you're pushing, that will, if you want to, okay, let me conclude this first. If you're pushing, you need to push harder than pulling. That's very clear, right? But if you want a very close shave kind of scenario, that is, you want to make it as small as possible, the grass cutter. If you want to make the grass as small as possible, you have to do this. But if you just want to casually pull it around, this is the best way forward. So all this is small, my bad. This was supposed to be just drawing and not. This is your f sine theta and this is your f cos theta. And that's that. Okay, guys. Okay, you can pause, have a look. One small note. Guys, all this has to do with the same concept over and over again. In this case, the friction concept is a bit extra. But if not, it's the same thing again and again. So my advice is, please don't just watch it. You need to pause, try, resolve vector, write add and subtract and things, get an expression. So you might stumble here and there. You might make some silly mistake. But if not, you will get the same expression and it's very simple. I'm not at all doing anything complicated. Learn the basics first. Then we'll go into your NEET, JEE or any other exam, entrance exams, question and answer. There we will use shortcut and it won't be this detailed.